Hello, I'm Ashley Galligan, and my MOOC project is on the degradation analysis of biomaterial in its environment. Before I get more into my poster, I want to share a little background into the corrosion process itself. What we have here is a stainless steel cannula needle. And somewhere along this needle, we have a crack, a crevice, a grain boundary. And then within this needle, we have pharmaceuticals. And now, specifically, we have saline solution and with that water, which becomes important later on. And so at the bottom of this crevice, we have titanium carbide, which is important because we hypothesized that titanium acts as a cathode to the 304 stainless steel, which is our anode, to complete a series of redox reactions. And so what happens is one of the elements of our stainless steel, iron, is the easiest oxidized, and that becomes iron 2+, along with 2 electrons, which then react with our water to form hydrogen gas and our hydroxide ions. And those hydroxide ions can then come and react back into that crevice or crack and continue this corrosion process. And so the idea behind my MOOC project was we were going to focus on this corrosion process, both the time sequence and what's happening chemically throughout the entire process. And so what we did was we took a look at this corrosion site, and we found the elements that are known to easily oxidize, like iron, chromium, and manganese, are not found in or around the edges of this corrosion site because they're being oxidized, which is thus creating a bigger and bigger corrosion pit. And so then another thing we did was we analyzed titanium concentrations in both a corroded needle as well as other 304 stainless steels. And so what we found was that a corroded needle had 3 times weight percent of titanium than any other supplier of 304 stainless steel that we tested, which brings us to our current look, which is an accelerated corrosion study. And what we're trying to do with this is confirm or disprove the hypothesis that titanium acts as a catalyst for corrosion, specifically pitting corrosion, as well as to get an idea of how this corrosion progresses and what's happening both as a time sequence and chemically throughout this process. And so I look forward to hearing any questions that you all have, and I hope you enjoy reading the rest of this poster.